Welcome to everybody. Thanks for braving the snow. Someone online did apologize for not biking through the snow, but you're completely forgiven. So thank you for joining us today. This is actually the final talk in our annual BoulderTalks Insight from Education Innovators series. This series came about from a desire to bring to campus visiting experts who are innovating quality online education and educational technologies. Through this community, we hope to explore current themes like learning excellence, innovating credentials, scaling degrees, expanding access and opportunity, ensuring success across multiple modalities, and incorporating new educational technologies. So as is the case with so much of what we do in online education, this speaker series really is a community effort. So I want to recognize our co-sponsors for this event. That includes the Center for Teaching and Learning and the Office of Information Technology, Continuing Education, University Libraries, Office of Digital Education, and the College of Engineering and Applied Sciences, and the Office of Academic and Learning Innovation. All right, so I'd like to introduce our speaker today. Dr. Jules White is Director of Vanderbilt's Initiative on the Future of Learning and Generative AI, Professor of Computer Science in the Department of Computer Science, and Senior Advisor to the Chancellor at Vanderbilt University. He created one of his first online classes for prompt engineering, and his online courses have had over 630,000 people enroll and have been covered in media outlets such as the Wall Street Journal, CNN, and The Guardian. He won the 2024 Coursera Innovation Award. He is a National Science Foundation Career Award recipient. His research has won multiple Best Paper awards, and he has published over 170 papers. He's also an inventor, multiple patents, and has launched several venture-backed startup companies. So with that, I'd like to welcome and invite Dr. Jules White.
So thank you for having me. I always start all my talks the same way on this topic. And I say, I'm really passionate about this topic. And the reason is because if you'd stopped me on the street November 1st of 2022, and you'd said this thing called ChatGPT is going to come out at the end of the month, I would have told you, trust me, I'm a professor in computer science. I will not live to see that level of advance in computing. And then a month later, something would have come out and did come out that I didn't believe would exist in my lifetime. And what really got me excited about this topic is that when I looked around to see how people were innovating with the most important computing advance of my lifetime, I saw that people were really focused on student cheating and Terminator. And so to me, that seemed like an opportunity to go and look and reshape how we're approaching this technology. Now, if you've taken some of my courses, I apologize in advance. You may have seen some of the first few minutes of this talk, but by the end, I promise you'll see some new stuff. So I went off and created a number of Coursera courses. I started thinking about how do we teach this and teach it as a different way of approaching computing and rethinking what we can do in computing because of the capabilities. So I created a number of online courses. They've had over 670,000 people enroll in them today, and over 1,000 companies are paying for their students to go through them. But the real thing that this gives me is I get insight into what all of these different companies are doing with generative AI and agents, and all of the ways that it's going to impact the world, but also what we need to teach our students and how we need to prepare them. So what I'm going to try to do is give you some insight on some of the most important things that I think are happening, but also perspectives on how we need to think about approaching computing in the era of generative AI and AI agents. So the first thing, and if you were in the workshop earlier, you heard me say this already, but I think it's the most foundational thing that people miss, is when you approach this technology, so many people approach it as question and answer. Like I ask it a question, I get an answer, and the answer is either right or wrong. And if it's wrong, I'm like, well, the models aren't quite smart enough yet. Like I'll have to wait around till this AGI thing happens so it can solve my problem. And that's not the way you want to approach these models. You want to approach them and you want to think about solving problems through a conversation, where you're going to go and iteratively refine some content, explore some ideas, produce something important. And you do that through more than one prompt, through more than one interaction. So I'm going to give you a simple example of solving a problem in conversation. So here's the simple task I'm going to give to ChatGPT. And this is ChatGPT from January of 2023. It's like ancient technology. Please create a meal plan for my family that is based on a fusion of food from Ethiopia and Uzbekistan. I want to eat keto and up to 2,000 calories per day. Pick dishes where the ingredients are easy to get from an average US grocery store. So this is an easy task that I don't think that there's a human being in Nashville where I live, or probably Boulder, or probably the United States that can do it as fast or as well as ChatGPT. So what does ChatGPT say? Here's a sample meal plan. Breakfast, scrambled eggs with sauteed onions, tomatoes, and Ethiopian berbere spice mix. And then notice what it does, in parentheses, made with chili powder, paprika, garlic powder, ginger, cumin, and coriander. And it's signaling to us, these are ingredients that you can get in an average US grocery store. Absolutely nothing that we had in computing could go and compute an answer that understood average US grocery store. Now, a lot of people take issue when I say understands, like, does it really understand? And as a computer scientist, my answer is, I don't care, right? I now have a computational tool that allows me to generate an answer that approximates what's in an average US grocery store. And that is a really powerful capability that did not exist in computing before. Now, a lot of people look at this and they say, you said 2,000 calories per day, and it failed on the most basic thing, which is it didn't give you any serving sizes. And so if you really care about serving sizes, you've got to start thinking in terms of conversation, and you just follow up in the conversation. And you say, can you give me an approximate serving size for each dish that is within my 2,000 calorie limit? And it comes back and it says, breakfast, 2 eggs, half a cup of onions, half a cup of tomatoes. And now we have serving sizes. Now, from my perspective, when people go and they do it in this one-off fashion, where they ask a question and they get an answer and it's either right or wrong, it's like if somebody handed Michelangelo a new hammer and he walks up to the stone, he whacks the stone with the hammer and he looks at it and he's like, oh, it's not a beautiful sculpture. And he throws the hammer down on the ground. He's like, it's a terrible tool. Why would anybody use it? No, that's not what he would do. He would continue to chisel away at the stone until he has a beautiful sculpture. And he also understands that his skill with the tool is equally important. And that's the way we have to approach generative AI. And we have to realize that we've never done this before. We don't know how to use it and we're discovering it. We have to have patience and develop our own skills. And that's a critical part of the success. Now, if we look at this, we could criticize it further and we could say, it says half a cup of onions. And I could say, I don't know if that's keto enough for me. Like maybe that's too many carbs for breakfast. And I could continue to refine the macronutrients, but I'm going to take this conversation in a different direction. I'm going to solve a related problem that I have to it. So I'm going to follow up in the conversation. And the real problem is that I have a 9-year-old at home. Now he was now 11, been doing this example for a while. And my real problem is, how am I going to get him to try these dishes? I have a marketing problem at home. So I follow up in the conversation and I say, my son is 9. Sometimes he won't try new dishes. To make this culinary adventure more fun for him, can you create a short Pokemon battle story to go with each dish? I'll read the stories with him before dinner to get him excited about trying the new food. Make sure the story ends with a cliffhanger that will motivate him to try the food. Now, I don't know about you, but I'm not particularly good at keto, Uzbek, Ethiopian meal plans. I'm really not good at turning them into Pokemon battle stories that end with a cliffhanger to motivate a 9-year-old. But it turns out ChatGPT is pretty good at it. Story. Pikachu and his friends were exploring the wilds of Ethiopia when they were suddenly ambushed by a group of sneaky Pokemon thieves. As they raced through the dense jungle, they stumbled upon a hidden cave filled with treasure. And then it goes on and it says, in the end, they emerged victorious, but not before the dragon left a fiery spice that imbued their breakfast eggs with a flavorful kick. Can you help Pikachu and his friends defeat the berbere dragon and enjoy the spicy breakfast? So it understood the context of this breakfast dish and motivating a 9-year-old and ending with a cliffhanger to try to get him to eat it with a call to action. That's essentially personalized marketing for that kid. And what did I do to get there? Just a couple of sentences. Go and generate this. But nothing we had in computing could do something like this before, because we had rigid computing that works on plus, equals, if, else, for loops, all kinds of things like this. We didn't have things that said, create a motivating story for a 9-year-old that ends with a cliffhanger. That wasn't an operation we had. And then I started thinking about it and I thought, well, what else could we do to make this sort of culinary adventure more fun for him? And I thought, well, we love to talk with him at the dinner table about what he's learning in school. And he loves math and he loves to play math games on the iPad. And I thought, wouldn't it be cool if I could get ChatGPT to play a math game with him? So I followed up in the conversation and I said, I'd like you to play a math game with my 9-year-old to teach him about division with fractions and nutrition. Ask him questions one at a time involving Pokemon in these topics and make it into a game. And I'm beginning to use techniques from prompt engineering of knowing how do we structure the conversation and use different building blocks to achieve different computational effects that we want. So what does ChatGPT say? Great. Question 1. Pikachu and his friends are planning a meal that includes half a cup of cooked rice, but they need to divide it evenly among 3 Pokemon. How much rice will each Pokemon get? And then what does it do? It stops and it waits. It waits for his answer because it understands the concept of a game and it understands that it's his turn to respond. And when he types in 1-6, which is the correct answer, it says, good job. It works out the math for him. Then it goes on to the next question. Ash wants to make a smoothie. And with just a couple sentences, I've created a personalized educational game for my son that will go and ask him questions on this topic in perpetuity. Now, as a computer scientist, I could go and write software to do this, but it's not 2 sentences. It's like hours or days of my time. And then I still have to go create the content to actually go in the game, all this Pokemon smoothie content. And if you think about how transformative this is going to be in all the different ways from personalized education to marketing to software design, it's really profound what it's capable of. Now, the other thing that's really interesting that we're starting to see here is we think about asking these models questions and telling them what to do. But as we're going to see also throughout this talk is they can ask us questions and they can tell us what to do or a computer what to do and guide us through complex topics. And then finally, being a computer scientist, I thought this is great that he can play the game in ChatGPT because he turned it into real working software. So I just followed up in the conversation. I said, let's create code for this in Python. And then I gave it some of my domain knowledge. And Python's a programming language, and it goes through and it generates the code. And this is a snippet of it. And then this is a working application that he can now play on a browser, on an iPad, or a laptop. Absolutely nothing that we had in computer science would allow us to so fluidly explore so many dimensions of this meal plan and the education around it and the marketing around it, like that allowed us to go and do things like this with computation. And so this is a game-changing capability. Now, it's changing our interface to computing, just like we saw. I went and played this game with him, allowed me to create this educational software, but it's going to transform basic things that are done in every single discipline. So I'm going to give you some examples from Vanderbilt. So this is the Vanderbilt travel and business expense policy, and it is a 17-page PDF. And I always joke with people and tell them, you know, I've had many expenses rejected because of this thing, and yet I've never bothered to read it. And that used to be true until a couple of years ago. I read it with ChatGPT. So I uploaded it to ChatGPT, and I said, please read the provided document so you can answer questions about it. And then I asked it a question that actually looks like the questions I ask. Let's assume I'm in a foreign country traveling in a taxi, and it breaks down on the way to an important meeting. Can I get reimbursed if I pay someone to drive me in the back of their motorcycle to the meeting? Assume they are a private citizen. What does ChatGPT say? Based on the information provided in the document. So there's this assumption that it's so difficult to go and have these models work with your information. They're going to hallucinate because they don't know all your private information, but it's as easy as going and adding an attachment to an email to get it to reason on your documents, your policies. Then goes on and it says the university requires travelers to select the most reasonable and economical form of transportation. That's true. It's a direct statement from the document. Non-conventional transportation options are not explicitly mentioned. Vanderbilt does not have a separate policy on ride sharing. That's also a direct statement from the document. And it says, given these points, it seems plausible that in an emergency situation where no other reasonable and economical form of transportation is available, the cost of transportation by a private citizen's motorcycle might be considered an allowable expense. However, the university's policy does not explicitly state this, and reimbursement may be subject to review. And if you've been at a university, you know, this is a very accurate statement. It might be allowed. It will be reviewed. And I read it to all the chief business officers of Vanderbilt, and they all nodded. It was all fact checked. And so all it did was took the document and applied a very complex operation on it. Now, we've had tools for a long time that we could go and ask questions in natural language and get text back that appeared to answer the question. But it is a very different thing to understand the content of the document well enough to apply it. So I followed up in that conversation and I uploaded a rental car receipt. And I said, please analyze the attached receipt and let me know if it complies. And it comes back. And I want to draw your attention to this highlighted portion at the bottom. Collision damage waiver. For domestic travel, the CDW should be declined as rental vehicles are fully insured through Vanderbilt's insurance portfolio. The receipt shows a charge for CDW, which may not comply if this is domestic travel. So it read the policy and it understood it well enough to determine that the receipt was out of compliance and why. Now, again, as a software engineer, I could write software to do this, but it's not me. It's me plus a team of people in probably years to even approach this level of sophistication. And I did this by simply saying, go and read the document and apply what you've learned to this receipt. That's not something internet search could do. This is not something that none of the tools that we had of the past could do. This is the Vanderbilt Instructional and Enrollment Report. It's a 20-page PDF of these tables. And before, if I wanted to go and do work with it, what I had to do was probably go and copy and paste out of this PDF into something like Excel. And then in Excel, I could go and visualize what I want or calculate what I want. And I have to do that because our software tools are frankly terrible. They don't talk to each other. Everyone has a different interface. They require all this training. So I'm going to upload this to ChatGPT. And I'm going to start off with a really simple task. Please extract each page of this PDF as plain text in a separate file. And it goes and it pulls the PDF apart, and it gives me links to download each of the individual pages. Now, this is interesting, but we've had tools like this in the past, like Adobe Acrobat can go and pull a PDF apart for you. So let's do something more interesting. I did a little prompt engineering, and then I said, turn it into Excel for me to download. And it goes and transforms it into an Excel file that I can now click and download. And so it's now beginning to solve this problem of all the incompatible pieces of software that we have. But I thought to myself, like, why would I even go to Excel when I could just follow up in the conversation and say something like this? Display 4 interesting visualizations of this data. And it comes back and it generates the visualizations. And now as fluidly as I can think about what are the questions I want to ask, what do I want to explore, I can go and get the analysis done. And then, of course, thought, well, what else can I automate in this? And I thought, well, I really hate doing PowerPoint. And if I'm doing visualizations, it probably means I have to go get a presentation. So I uploaded my slide template for PowerPoint. And I said, save each visualization as an image, then insert each of these images as separate slides into the attached PowerPoint. And I gave it information on how I wanted it laid out. And I said, put a little text box next to each image describing what it shows. And it goes and it generates the PowerPoint. And when I download it, this is the PowerPoint open that it created. Each of the visualizations has been turned into a separate slide. Each one has a text box next to it describing what's in it. And now I can focus on what are the questions I want to explore in the data? What is the message that I want to communicate? And this is, in complete contrast to the way we work today, which is like, how do I get all these different software tools to help me solve the task? Now I'm having this totally fluid and cohesive interface to thinking about what is it the problem I want to solve, exploring it, and I don't have to worry about what individual tools I'm trying to work with. Now, this is really radical because it changes the way that we work with computing, right? We're not going to be working with all these individual tools, hopefully, in the very near future. Instead, we're going to have this single interface. But to make this happen, something absolutely incredible takes place behind the scenes. And this is something I still today think it's insane that we haven't seen news stories on this because it is so wild. And as a computer scientist, I'm still dumbfounded that it's possible. So I want you to imagine that you go into your backyard and you pick up a shovel. And right before you go to dig a hole, your shovel jumps out of your hands because it sees a rock in the way. And then your shovel builds itself a pickaxe and it uses the pickaxe to break up the rock. And then it jumps back in your hands and you continue digging. And then as your tool saw that there was an obstacle in the way, it built itself a tool to help overcome the obstacle. And all of this happens seamlessly while you're using the tool. And that's exactly what happened in this conversation with ChatGPT. So I'm going to show you an older interface to ChatGPT because they made this more obvious that it was happening. So used to when you would go and work with data and visualizations in ChatGPT, as you were asking questions, these big gray boxes would pop up. And that's ChatGPT building a tool. And if you clicked on the gray box, it would show you the tool it built. And the tool it built was software. So as you were asking it to go and do things like create these visualizations, then turn them into images and turn them into PowerPoint, it said, I can't do that as a model, but I can write software that can. And so it wrote itself a software tool to do that. It executed its own software tool. It looked at the result and kept iterating until it got it right. And then it just handed back to me the PowerPoint. And that is, we have tools now that can go and build tools. Now, I showed this code to my graduate students in my PhD level class in software engineering in the age of AI. And said, we had like 30 minutes left in class. And I said, how many of you from scratch could write this code given the remaining 30 minutes? And like no hands went up, including mine. And so we have tools that are not only building tools, but they're building tools at like superhuman capability. And this is an amazing thing. You think about it, when chimpanzees use blades of grass to extract termites from termite mounds, everybody freaked out and said, look, animals are building and using tools. And now we have software that's building tools autonomously at superhuman capability. So two things are happening in computing. One is generative AI has fundamentally new and unique capabilities, the ability to go and build that Pokemon story and have it end with a cliffhanger. But it's also a new interface to computing. And suddenly you go and start communicating what you want to achieve, what are the goals, and it fluidly puts the computation together to make it happen. Now, these two things are going to change everything that we do in computing. Now, one of the other things that's absolutely amazing that many people don't understand about generative AI is that it can see. And this is called multimodal prompting, basically where you give it things other than just text, like images and video. So I'm going to give you an example of this. So the other night, we went to a Tex-Mex restaurant with some friends, and the friend sitting next to me was a lawyer, and he said, I've never touched ChatGPT. It makes too many mistakes. It's not very interesting. And I was like, really? And I felt bad for the guy because I wouldn't shut up the rest of the night. And so I snapped this picture of the table, and I said, who needs a refill? It's a really simple question that a human can answer easily and would have been tremendously difficult with previous computer vision technologies. And it comes back and it says, it looks like the glass with ice water is still fairly full, while the beer bottle seems to be nearly empty. So someone might want to refill on beer soon. One sentence, I've created a new operation, a new detector, a refill detector. To do that with traditional computing is enormously difficult, if not near impossible. And then because I was blabbing on and doing this little demo, I hadn't ordered, and the waitress walked up. And so I snapped this picture of the menu and I said, I'm feeling indecisive and out of time. The waitress is here. Everyone is waiting on me. I need a quick keto option. And it comes back and it says, go for the grilled chili relleno with smoked chicken and sliced avocado. It's a keto-friendly option. And so I simply took a picture, and suddenly that picture is as good as data. It can go and compute an answer on it. If you think before, I'd have to have like a database and like some way of searching based on keto and what that meant. And I just go and snap a picture of it, and I now have one of the most sophisticated ordering machines on the planet. Or if you've ever been in a classroom or brainstorming and you wrote something on the board, why write it down anymore? You can just snap a picture of it, and say something like this: everyone agrees that we should implement this new grading policy. And it turns it into text in an email. Now, a lot of people wonder, like, how good is this vision really? Like, is this really the world's most advanced state-of-the-art computer vision? And so I'm always trying to test it and make sure, am I really sane? Is it really that good? So I found this picture on Amazon, and it's silicone squirrel finger puppets. And so I uploaded it to ChatGPT and I said, how many squirrels were hurt in the making of this photo? And it comes back and it says, it's likely that no squirrels were harmed. The image appears to show novelty or costume finger puppets designed to look like squirrels. Such products are typically made from materials like rubber or silicone. Good luck, computer vision specialist. That is absolutely transformative. And anybody with their phone can now go snap a picture or take a video and have the world's most powerful computer vision and combine with the world's most powerful reasoning, and you can do unbelievable things. And we're going to see a bunch of those in a minute. Now, one of the things that people always ask me is, everybody is so bent out of shape about this dirty hallucination word. They say, but it hallucinates, it makes stuff up. And to me, hallucination is one of the most important new forms of computation. It is a new operation that we can do in computing we have never been able to do before. And it's wildly exciting because I think if we didn't have hallucination, nobody would really care about this generative AI stuff. So let me give you an example. So I'm always trying to think about how do I teach this world of generative AI to my son? He's 11, and 7 years from now, who knows what he's going to be experiencing in the world. His school's not teaching it yet, but I want to make sure he learns it at home and has a way of thinking about it and reasoning about it and understanding what to do with it. So the other morning I got up and I sat down with him and we built this prompt together. So here's the prompt. I'm going to take pictures of things. And whenever I take pictures of things, you give me a crazy fun, totally unique new game that I could play with them. And he took this and he immediately knew what to do. He had my phone and he went, and he's like, I'm going to break ChatGPT. And he collected this old wooden ship, a remote control, and 3 wiffle balls in the box. He's like, let's see what ChatGPT could do with that. And I thought, yeah, let's see what it could do with that. That's pretty hard. Like, as a computer scientist, I can't solve this problem with traditional computing. And ChatGPT is pretty good at it. Remote control shuffleboard. Slide the boxes along the wooden plate to score points by landing in specific zones, and then had all the instructions on how to play. And then he went around experimenting, like grabbing old toys and things and weird stuff and putting it together and like seeing what games and ideas it could come up with it. We could not do that in computing. Like creativity, imagination were not operations that a computer could perform. And now it's a fundamental part of these models. And it opens up a whole world of opportunities to do really powerful things with the idea of having a computer that's now creative. It's very different from the way we did computation before. It freaks people out when it makes stuff up. And I'm so happy it does because I think it's really important. Now, a really simple practical problem that you can solve with this, and I'm betting at least one other person in the room has experienced this, is you don't plan your grocery shopping very well. And you get home at the end of a very long day, and you're like, oh man, I have nothing left. What am I going to make? And for like years, my answer was, I'm going to order out, go buy something. Now you can just assemble what you have left, ingredient-wise, and say, this is all I have left in the pantry. Give me a dinner recipe. And it comes back with black pea and avocado salad with yogurt lime dressing. I don't know if any of you saw that. I did not see that when I first took a picture of it. And then if you go back and you're like, well, you know what? I don't really want peanut butter in it. Okay, fine. I can redo it again. I don't want this. I have this allergy. I want this sort of flavor. And as much as you can go back and continue to converse with it, again, conversations being so important, it'll continue to imagine and create new ideas based on the constraints of what's around it. That's a transformative capability in many different ways. Let's look at some practical, really practical applications of hallucination. Yeah, I think it's pretty practical at home for cooking. One of the really interesting ways that we can use this is we can use it for all kinds of things like human collaboration and problem solving. And it may be like, well, how on earth are you going to use it making stuff up to help a human solve a problem? Let's take a look. One of my favorite things is that people are always asking me like, isn't AI biased? And I'm like, yeah, it is. And the source of that bias is the human beings that created all the training data that went into it. And what's fascinating is the way that we did AI before, we had no solution for this. You like put something into AI, it gives you an answer. It predicts something. It can't tell you why. It's extraordinarily difficult to try to get anything reasonable out of it. And human beings, even without AI, are biased. They look at data and they have confirmation bias, all kinds of other biases. Well, it turns out generative AI can actually help us solve this. So you can say, for example, please look at the data and generate 3 conflicting interpretations of it. And it can look at your data and it can argue multiple sides of it. And now you can use it to help make sure that you don't have confirmation bias or that you're not missing some important side of the issue. And that's something we never had before, is something that gets support sort of human reasoning beyond just like try to come up with an answer. Or team meetings and meeting transcripts. This is one of the ones that I'm just like blown away at how short-sighted all of the meeting companies are, all the Zoom transcripts and all that. Like the end all be all that they believe of generative AI applied to meetings is summarize the meeting you just walked out of. Like, I cannot think of anything I'd want to do less than read a summary of a meeting I just had to sit through. So let's do something more interesting with it. we can take a meeting transcript and we can upload it. And we can say, please review the meeting transcript and identify 3 potential ambiguities for the team to discuss. And it will read it and it will do a really good job dreaming up potential ambiguities. Now, worst case, it comes up with something that everybody agrees on. And you've talked about it a little bit more. And suddenly you've helped the humans collaborate by having it dream up what might be ambiguous. Often, it will come up with really good things that maybe you didn't think of. Another great example of this is something that has plagued software development for the longest time, but I think it applies to many other domains. And it's this fundamental problem where you have 2 teams that are working on different parts of the same problem. And at some point, those teams and their decisions have to come back together and you have to integrate them. In software, you have like a team working on the front end of the thing and you have a team working on the back end and you try to put the software together and it doesn't work because they've made conflicting decisions. And we had no solution to this before other than trying to get better processes. You can take the transcripts from 2 different teams and you can upload them to a tool like ChatGPT. And you can say, here are the meeting transcripts for 2 different teams working on different parts of the same problem. List 3 potentially conflicting decisions they made. And it can read through the transcripts. It can understand the semantics of what they're talking about. And it can list things that may conflict. To do this, it has to dream up ideas. They may not be right. They may not be factually accurate. But it is beginning to, approach a solution to something we've never been able to tackle. Now, we've heard a lot about AI agents lately. And I want to go back to this idea of tools, because tools are something fascinating. And we have this sort of notion that tools are like a key mark of intelligence. And so let's take a look at what that means in the context and what an agent is. And so we're going to build a really simple agent, and then we're going to look at what it does. So we're going to build an agent that is going to help us escape from an alien spaceship. And we're going to equip it with a bunch of tools. And this may seem crazy, but basically all the agents you're hearing about, behind the scenes, they are pretty much this simple. So here's what we're going to do. We say tools, and this is one prompt to ChatGPT. And then we give it a list of tools. We have the X155 tool, which we tell it prepares an alien pizza. We have the Q63 tool, which we tell it opens a dimensional portal to a configurable destination. And then the L199 tool, which causes the ship to play Beatles music on a loop. Then we tell it, I'm trapped in an alien spaceship. You're going to help me escape. Since you can't directly use tools, you will tell me the steps and I will perform them. Each step must use a tool. We will go one step at a time. Tell me the first step. And roughly most agents have some formulation behind the scenes like this. Here's a set of tools. You get to use one tool at a time, try to solve this problem. In this case, our problem is how do we escape the alien spaceship? Anybody see the solution? I'll be fascinated if yours is as good as ChatGPT's. Step 1, prepare an alien pizza. Use tool X155 to prepare an alien pizza. This will serve as a distraction for the aliens as the aroma and activity around the pizza preparation will draw their attention to you. And then it says activate the tool X155. And then I tell it, okay, I've done that. So I give it feedback on what happened, like I've completed that step. It says, okay, step 2, open a dimensional portal. Use tool Q63 to open a dimensional portal. This portal will be your escape route leading to a configurable destination away from the alien ship. I tell it, okay, I'm done with that. Step 3, distract the aliens with music. Use tool L199 to cause the ship to play Beatles music on a loop. This will create an additional layer of distraction, making the aliens focus on the music and further reducing their attention on your escape. Activate the tool. Once the music is playing and the aliens are sufficiently distracted, proceed through the portal to escape. It just went and took tools and put them together into a creative way to solve the problem of how do I escape an alien spaceship. Now, if you hear about agents, this is what an agent is, except the tools are, you can call this piece of software on my computer and you can talk to it and you can tell it to do something. And the agent basically gets the ability to actually use the tool, which is to call that piece of software. And rather than me, the human, telling it what happened, the software gives it feedback. It gives it output. And it looks at the output of the software and it says, oh, that's what happened. Okay, this is the next step, and it decides the next tool to use. And all of these agents that you hear about are essentially the generative AI having a conversation with a computer, where at each step, it's choosing a tool that is some piece of software to go and use. And the feedback, the other side of the conversation, is the computer telling it what happened. And then it decides the next tool, and it keeps going until it's decided that it solved the problem. And this basic conversational building block becomes one of the most powerful computing tools that we have, because now you can go and equip a piece of software with a set of tools, and you can say, here's what I'm trying to accomplish, like create this PowerPoint presentation and do all these other things. And one of the tools that we saw that ChatGPT was using is the ability to write and run code. And in fact, that's a really powerful tool. Is you simply build an agent. You say, if you need to run some code, you can write code and run it with this tool, and it will go and run the code on your computer. But typically we use things like check my calendar, send an email, things like that, and those become tools, and you can build really powerful things. Now, one of the exciting things for me as an educator is that we've always had certain ways of capturing knowledge, but they tended to be pretty static, right? And I think there's this exciting new opportunity of using generative AI to create what I think of as live knowledge. Basically, knowledge that is instantly available, context aware, and responsive to the user's current environment, needs, or actions without requiring deliberate search or transformation. And of course, I use ChatGPT to help craft that definition. So let's take a look at what this looks like. So let's say that you have a mission critical piece of machinery and you're having trouble using it. So in this case, it was a coffee maker in a hotel room. So I snapped a picture of it and I said, explain to me step by step how to use this. And it comes back and it says, here's the steps to use this thing. Now, if you think about it, in the movie The Matrix, there's this scene where Trinity needs to fly a helicopter to be able to save everybody, but she doesn't know how to do it. And this operator in this, back in the real world, downloads the instructions into her brain, and then instantly she can go and fly the helicopter and save everyone. Now, we're not quite there yet, but this is approaching that level where I need to be able to use this, do this right now, and on demand, we can get instructions and training to do that. It also creates this ability to go outside the classroom and create all kinds of new and interesting experiences. But it's not just that it can come up with a set of steps of how to perform the action. It can go much deeper. And it's related to that AI agents thing that we just looked at. I'm going to give you an example. So this is some leftover sushi from my fridge. And I snapped a picture of it. And I said, give me step-by-step plans to make this. And it comes back with a complete list of ingredients like sushi rice and cream cheese and nori seaweed sheets. And then it gives me a complete list of instructions to make it. Now let's just pause for a moment. If this is all that generative AI was create a system that you can take a photograph of an arbitrary object and it will give you an approximation of how to make it. This would be the most important advance in computing of our lifetimes. And this is like one of like an infinite number of things that we can do with it. Like if I, as a computer scientist, had to team up with a bunch of PhDs, it would be like all PhDs and all supercomputing, and we probably still couldn't have done it. And now you just go and say, give me step-by-step instructions how to make this, and it gives you an approximation. It may be perfect, it may not be, who cares? It's unbelievable. But what's amazing is not just that it can give me the instructions how to make it, it's that it can continue to guide me through it as I try to make it. So if I go and gather all the ingredients, and I get Cabernet Sauvignon cheddar cheese spread rather than cream cheese, and I get yellow rice rather than sushi rice, and I get seaweed snacks rather than nori sheets, and I say, here's what I bought, what did I forget or get wrong? It'll come back and say, well, you got Cabernet Sauvignon and cheddar cheese spread instead of cream cheese, idiot, and yellow rice instead of sushi rice, and roasted seaweed snacks instead of nori sheets. And it's not just that it can tell me how to do it, but it can be there with me. And we think of telling it what to do. It can tell us what to do and correct us and help us understand where we're going wrong. And this is a transformative capability in computing, the ability to be so flexible in terms of the input and the feedback it's receiving and adapt and guide in a meaningful way. That's going to be transformative in all kinds of domains, from on-demand training to agents. In fact, the whole basis of agents, of why they work so well, is because they can adapt on the fly and do the equivalent of this with a computer system. When the computer system is slightly off, it can look at why and fix itself. Now, one of the other things that's really exciting to me about this is going to be the most democratizing moment in computing of all time, my opinion. Because computing was always something where you go and hire a software engineer to do something. You get a computer scientist. You have a great idea, great. Now go hire the person who's actually going to implement it. And it sort of locked out a lot of people from innovation with computing. And that's about to change. So the other day, I was talking to my son, and my son's always liked to collect things. So when he was little, it was like rocks and sticks, and he wanted to put them in the car. And he got older, and it was like Pokemon cards in the grocery store, and they need to come home with us and be scattered across the floor in his playroom. And then he's gotten older, and now it's shoes. And so the other day I looked at him, and I was like, buddy, you know what you need? And he's like, what, Dad? And I was like, you need inventory management. And he's like, not another ChatGPT thing. And I was like, yes, sorry, buddy. So we built inventory management for him in one prompt. And here's the prompt. Whenever I give you a photo, create an inventory of what I gave you with approximate price. Keep the inventory up to date as I add pictures. And I handed it off to him. He knew what to do. He took a picture of his Air Jordans. It says, based on the photo, item, Air Jordan basketball shoes, description, red colorway. He went and took a picture of his old Vans shoes, comes back, updated inventory. Now we have Air Jordan basketball shoes, Vans skate shoes, black colorway with white stitching, condition heavily worn, approximate price. And in like 3 sentences, we created probably what is one of the most advanced inventory management systems on the entire planet. It's preloaded with basically every object you can imagine. It can detect things like condition, approximate price that are incredibly difficult to do. And the future is going to be people at the end of the computer basically saying, I don't like the way this thing works. I want something that works differently, that adapts to my way of doing this. And they're going to be able to describe what it is and have it realized. And they're going to have agents supporting them in doing that, describing what they want to happen and having the agent carry it out, or describing the system that they want to be built, and it's going to be built. And it's going to empower the end users to think about how do we redefine what we do and how we build it. And I was super excited about this example because we went to New York last summer, and we were in the Nike Innovation Store, which is a very expensive trap for parents. And my son walks up to me with a shoe. He's like, Dad, I want to buy the shoe. And I look at it and there's no price on it. And I'm like, sorry, buddy, it doesn't have a price. That line's really long. I don't want to wait around and try to figure out how much it costs. He's like, Dad, give me your phone. And I was like, no. He took it out. He took a picture with ChatGPT. Tell me the price of it. And it's like, it's this shoe and this price. And gave us links to it on the web. And he was right. And then we bought the shoe. So I think it's a really exciting time in computing. But I think the problem that we've run into is this term artificial intelligence. Because it has this like terrible connotation to it, right? Like an artificial substitute for human intellect. Like, I don't really want to be replaced with some, artificial substitute. So I think what we really need to be talking about is augmented intelligence. How do we amplify human creativity, critical thinking, and allow humans to go and solve bigger and harder problems? And so I always talk about this as it's like an exoskeleton for the mind that you put on to allow you to do new and unique things. But just like any exoskeleton, you have to learn to drive it. You have to learn to take it off so your muscles don't atrophy. But we have to realize this is a really exciting time because it's going to fundamentally transform what we can do in computing and empower all kinds of people across all kinds of disciplines to do amazing things that have never been possible in their discipline before. So thank you so much. I would encourage you to take my classes. I have my most popular one is prompt engineering for ChatGPT. And I also have some papers on this topic as well, and I'd be happy to answer any questions we have.
Thank you, Jules.